Hello, Sarah. Are you there?
Hey, I'm here.
Let me see if I'm here. Hey, it's you. What do you know?
We made it.
We made it. I can't believe it. Carmen just came down here too.
I shut my door so that Holly didn't come in, but she's very happy because she got her walk, so she's usually good to go.
Yeah, she's on the couch outside my office, but then staring at me, kind of
Mm.
like, oh my goodness.
Like
Well,
what do you think you're doing?
yeah, something like that. She's like, hey, do you mind if I sit in on this webinar, but from out here?
We are so lucky to have good doggies.
I know. I'm excited. I'm glad
Wow.
for her. I'm grateful for her.
How old is she?
11, but don't tell Kathy, but almost 12. So I'm not allowed to say almost 12, though I have to say 11.
11. Yeah, she's just a pup.
Huh. No, I wish. I wish I could make it go backwards.
I know. Like, so our Holly is probably 9,
Uh-huh.
and I have a deal with our vet. Our vet
Oh.
is responsible for her living forever, and she has accepted that. So
Oh, oh, good. Well, that's a good deal. I need to make that deal. Here, let's see. Do you see my screen?
I do. Let's see who we've got a couple people who have
Yep. Let me see what
joined.
I need
We've
to,
got Paul on too.
I know, I'm ignoring him.
Don't do that. He's so great.
I know. No, you're probably right.
Don't ignore Paul. Paul does so much.
Yeah, okay. Well, let's see this. I'll put this over here. I see Larry Saber is on too. Larry is a diehard ride or die. Hey, Larry. Hey, buddy. I know you can't talk, but I want to let you know that I was in England 2 weeks ago when I went on this great big gravel ride, and it was awesome. It was really amazing. It's 75 miles, a bunch of elevation. Some saddle soreness, let me tell you. But it was great. Well, what do you think? Is it straight up time to go?
I mean, it is. It's one
Okay.
o'clock.
Let
Well,
me
it's
see
one
what I
o'clock.
can let me see what I can do here. Okay, so welcome to our webinar on reliability thinking beyond equipment. This is uh I guess Sarah, I don't remember the last webinar you and I did together, but maybe it's been a couple of months.
Yeah, back when we had Martha on for
Oh, that's
talking
right.
about safety capacity.
Yeah, that was super fun too. Well, again, so for people that don't know us, I'm Brian and that's Sarah, and there's a little bit about us. And I wanted to say that this is actually based on a recent blog post, and if you can see that here. Let me see. I actually planned ahead for this. I was going to go ahead and post this in the chat function if I can figure out how to do it. Bam, bam, bam. There it is. And let's do this. Host and panelists. No, be smarter, everyone. There we go. So, yeah, so this blog post is really looking at reliability thinking. So we do, Sarah and I and Katie, and I guess others at Solagia, but primarily the three of us at this point, we're doing a whole lot of work in the world of reliability. But then we see these crossovers to the other areas where we work because actually about 50% of our business is in safety at Sologic. 25% is reliability, the other 25% quality and other things like that. And but the concepts of reliability really, I guess, transfer over to many other places, especially in safety or quality. And so I think those are going to be areas where we focus. But in any other place where there's process related sort of outcomes that we're trying to achieve, process related, that we're basically taking these concepts of reliability from machinery and equipment and we're applying them across the process. So I don't know, Sarah, does that match?
It does. Yeah, that definitely matches. I think, we often think about reliability as being an equipment focus or component focus. But what we're starting to see is that request to look at process or to look at a system and try to identify there how things succeed or how things fail.
That's right. So we were at a meeting with Sarah wasn't there, but me, some others from Sologic. We were at a meeting with one of our clients. They're in aerospace and they're in a highly regulated industry. And the folks that we were specifically working with are the regulatory compliance team. And looking at applying some of these reliability concepts to the regulatory process that they're under, a tremendous amount of scrutiny, rightly so. Like we want airplanes to fly and we want them to, be in compliance and make sure that they're building them and operating them in a way that is that's in line with that. But then if those systems break down, what can we learn from classic reliability thinking that we can apply to those sorts of systems? And then conversely, this is the wrong word. Alternatively,
Alternatively.
looking at a different play, different application, if we're looking at safety related processes, looking at safety related, I guess, procedures and the way in which people are conducting work and whether taking that through a safety related lens, we can apply a lot of this reliability thinking to that as well. And it's, I guess, a little more than just classic process FMEA, but PFMEA is a part of it. I don't know. What do you think, Sarah? Do we need to
That's
say
good.
more? I
No, I
think.
think that's what we're doing today.
Okay, good. Well, let's dig in a little bit then. So, just to sort of set the groundwork, traditionally, reliability is going to be focused on equipment uptime and then preventive maintenance. And predictive maintenance, too, is probably a good one to have in there. But reliability is really about understanding how any system consistently performs its intended function. Right. So, what do we need it to do? What do we expect it to do? How consistently does it perform that? How predictable is its performance? And equipment isn't the only thing that fails. We can also see failures in processes, controls, and workflows as well. So maybe we'll move into some definitions of reliability. And this is really an overall, like sort of the framework, I suppose, Sarah, how we would approach whether it's a piece of equipment or whether it's a system or a process or really anything where we're taking this thinking and applying it. And so starting at the top, maybe I'll just continue since I'm kind of on it already.
You're doing
Um,
good.
okay, good. Yeah, so big picture, system. So what's the overall kind of a definition of the system? And do we have a boundary around that system? In other words, where does the system start and where does the system stop? But then once we've defined what that is, then we need to understand and define, I guess, put a label on this is the thing that we need to do what we needed to do. And then from there, we break it down, subsystems, elements, right? So we kind of use the system as sort of the overarching, I guess, label, but then we want to break it down into its smaller systems, all the way down to what we're calling, in this case, the element. In the world of equipment reliability, we would call it the component, but
Mhm.
because we're broadening the definition and broadening the thinking here, we're going to call it an element. But and you can go down and down and down and down and down. And so I think that there's a certain amount of I guess there's a certain amount of scope that you have to define each time you're doing this. But essentially, these systems are going to fail at that elemental level. And so, depending on what we're looking at, we will limit the scope of how far down we go to basically that level of control where where the failure will have a negative impact on the system, but also the level of control that we happen to have over it. Once we
Yeah,
get,
that's what
yeah.
I was thinking about. Is it's like sometimes when we're doing these, we ask the technicians if we're talking about a component. We'll ask the technician, at what level do we get where we're actually doing the maintenance, where we're actually doing something different for this component?
Yeah.
Or if it's for a process step, it's getting into that level of detail where we're saying, where is it the step where we're actually taking the action or we're making the change?
That's right. So, in a piece of gear, a piece of equipment, sometimes we take it all the way down to the screws and the fasteners, but other times we
Sometimes.
stop at yeah, other times we stop at like a field replaceable unit, So it's like, listen,
Yeah.
if it's like I don't know, like a variable frequency drive or something like that. Well, maintenance people often aren't digging into those things to fix them. If it's something's wrong with it, they yank it and replace it, right? So we'll
Right.
take it to that level. And the same is true if we're applying reliability definitions or reliability thinking to processes other areas outside of strict equipment reliability.
Hmm.
But then once we dig down into there, we need to define function. And what does the system have to do in order to function successfully? That definition, often if you can imagine a team of people, that team of subject matter experts or people that know about the system or about whatever it is we're looking at, we need to define clearly what we need that system or that element to do in order to be successful. And then from there, we can clearly define what failure looks like. So now
Yeah.
we have a good reconciled understanding of what we needed to do and how it fails. And then from that point, we can start examining what we would call failure modes. And those failure modes are the ways in which that system or element would fail to perform its required function. We define consequences as well. So there's often consequences at the elemental level, but then if those consequences percolate up to the system level, we want to clearly define how bad that failure is going to impact the overall system, because not all failures are created equally. So we define consequence. And then after that, we decide what controls we might put in place in order to prevent those failure modes from occurring, or to make them, if sometimes you can't prevent a failure mode from happening, you don't really have an impact over probability, but you do have an impact on consequence. Okay, so you can control how bad it is if it does occur. And also, you can improve its detectability so that you have more foreseeability. You can see the failure mode coming from farther out, and so you can at least get out of its way. So,
Hmm.
overall, Sarah, right, that this sort of defines when we approach a piece of equipment from a reliability centered maintenance standpoint, this is pretty much what we're doing.
Yep. Yeah. No, I mean, we're calling them definitions here, but really this is our process. I mean, this is how we say, like, let's take a look at the system or the component.
Yep. And so we do it systematically. We break it down to a fairly granular level, depending on how deep we need to go. And it's not a one size fits all sort of scenario. We do that case by case. We make that definition case by case. So, well, let's dig into this a little further. So, when we think about this across discipline, uh, looking at the term system. In the world of safety or EH&S, we may find that as task. Like, so what task are they expected to perform? What is their job or what activity are they performing? Under quality, maybe it's the process that they're putting in place, or the build process, or the manufacturing process, or the I guess the repair process, or whatever it is that they're doing. Operations, we may look at workflow or what the operation actually is, right? So from a system standpoint, you're going to find sort of different, I guess, different examples of what represents a system as you move across these different domains. And of course, as you step down through element, function, failure modes, consequence, and control, they're going to have a specific manifestation as you move through these different, I guess, different domains, reliability domains. But at the same time, from a higher level, of course, they're going to all fit this general model. No, okay, we'll move on to the next one
No,
then.
well, I think that's a really, I mean, I think that's a really interesting side because really it's just taking the same concepts and applying them with different terminology, but
Yeah.
it still is the same approach and it's still the same ideas behind breaking something larger down into smaller parts and then understanding how it works. You know, how does it work first and foremost? What is the process supposed to do? What are we supposed to achieve? And then where those failures happen around that. So, I think that the translations that are in here are part of what really jumped out to me in this concept of
Mhm.
that we aren't just talking about one specific aspect. Like these same exact principles can apply regardless of which discipline we're sitting in.
That's right. That's right. I like the idea of translating between these different roles. And when you're somebody like us, when we're asked to come and apply these processes across these different disciplines, then I guess that is a translation. And that's sort
Yeah.
of that's what we go through. What would we call this in this particular world? Like at one of our clients, they're a major transit authority in a major metropolitan area. And so they're going to go through a process like this when they do something, when they have a major change, like put a new bus stop in place. Well, putting a
Hmm.
new bus stop in place is going to be a lot different than keeping like a piece of sortation equipment up and running or a big furnace or something like that. But then this allows us to take the same sort of overall skeleton, I guess, and then translate that across. Yeah.
Yep.
All
Yep.
right. So there, I know I find it interesting too. That's what sort of what makes this fun. Okay. So then I think Sarah, what we're doing here is, and this is Sarah's slide, right? So you
Oh,
uh,
thanks.
applying this to different areas, right? So maybe you can run with this one.
No, it's just that it's kind of re-emphasizing the different disciplines, but putting it into like an actual meaningful process or thing that somebody is working on, and kind of tying it back to what we do on the our usual day to day is with an investigation. It's still a process. It's still trying to understand the overall, get into the details, and understand what the controls are. But again, I think it's cool that this can apply across so many different types of industries, across different types of roles and different types of examples, but you know, we're still taking that same approach to understanding how to make something perform better. So I had a professor in college who would always say, our goal is to do everything on time, to specification, and within budget. And that's, I think, a big part of what reliability is about.
So maybe we should take a second here because and say that this is a proactive
Yeah.
activity, right?
Yep.
So normally in our world, in root cause analysis, if that's our normal world, which I'm not so sure it is these days. I mean, I think it's like our world is getting bigger. But we're looking retrospectively backwards at how failures occur. In this case, we're looking at how failures might occur in each of these areas. And we're using a lot of the same thinking, but because it hasn't happened yet, we're sort of estimating, we're dealing with sort of a probability cloud, and so it's definitely more of a application of risk assessment, risk control, versus a straight up investigation of how something did occur in the past.
Yep, absolutely.
Okay, so let's move on to the next one. So, looking at function, right? So, Sarah, I think that what we're going to do now is dig in to each of these just a little bit further. So,
Yep.
understanding function. So, in reliability, across domains now, because we're no longer just talking about equipment, we need to start by asking, what is this thing or process? What is it supposed to do? And everything has a function. So equipment, pump delivers water. In this case, a water pump does. Safety, lockout procedure. It's supposed to prevent unexpected energy release. In quality assurance, an inspection detects defects before moving on to the next step or before shipping the product or whatever it is. In operations, so I think the example here is like shift handoff. Process is supposed to transfer critical information between shifts. And then under leadership, pre-job briefings, aligning everyone's understanding before the work begins. And I suppose also providing an opportunity for people to express concerns and observations sort of on a job by job basis. So understanding what that function happens to be. And when we're applying reliability thinking, it helps us understand how systems shape outcome, right? So the way that I understand this is that we're creating systems in order to help us shape the outcomes that we desire or achieve the goals that we've set out or that we've defined, and the manner in which, and kind of going back to what your professor explained, the constraints by which we achieve those outcomes. I don't know. Is that what you think too, Sarah?
Yeah, well, and I mean, when we're doing investigations and we get to that scenario where somebody says, you know, they didn't follow the procedure, they didn't follow the process, they didn't do the steps, we kind of take this inherent approach of saying, let's understand what the steps were in the process, because
Hmm.
we want our steps to be performed reliably, consistently, with the same level of rigor that they always need to be. And so we have a set of steps that are usually defined so that we get to the outcomes that we're looking for. But it's when we don't
Hmm.
get there that we say, hey, let's take a step back and look at this.
That's right. That's right. So we have our plan, right? So if we were going to put this in human and organizational performance, I guess speak, we start out with where we are now, and then we know where we want to go. We know what our goal is, and our plan. We our I guess stated mechanism by which we're going to achieve that goal is sort of our work as imagined. In actuality, there is a bit of meandering. There are unexpected things that come up, and I guess that's normal for there to be some variation in how we actually put the plan in place. Those variables can be the result of plan gaps, but they can also be the result of the fact that we just don't always know how things are going to unfold. There is uncertainty as we move forward with any sort of a plan. That uncertainty is going to sort of barge in, and it's going to cause us to have to adapt and overcome, and that's something that humans are generally very good at. Um, and sometimes, though, we're not able to do that. And so when we're applying reliability thinking, I guess what we're doing really is we're putting a level of scrutiny to the plan to make sure that before we take a single step forward, we're trying to understand very clearly what is that goal that we need to achieve. And then clearly, what steps do we plan on taking in order to achieve it? And then what might cause those steps to break down or to fail? And in particular, what might cause the breakdown of those steps along the way, in specific, to really result in something that we can't tolerate, an intolerable outcome, such as an injury or a fatality or something like that, or the loss of critical equipment, some kind of intolerable loss. And so the reliability thinking really helps us by saying it helps us see how systems shape outcome. It also helps us see how the potential failure points in systems can result in outcomes that we don't want. So I don't know, kind of wanted to
Yeah.
expound
Well,
on
I
that a
think
little
that
bit.
that's a nice segue for what we were planning to talk about next about how, when things are not reliable, what it looks like. Because
Let's do that.
you're starting to list those.
Yeah, let's do that. So, some of those outcomes, the appearance of unreliability, things like injuries, obviously, that seems, some of these are going to be obvious, but releases and the uncontrolled release or loss of containment, rework or scrap. So, in processes, downtime, unplanned downtime, which is the sort of the classic outcome that we're often looking at in the world of equipment reliability. Emergency repairs, that too. Customer complaints. So when quality is off, if you're whether it's a product that you're making or whether it's a service that you've provided, investigations. Oh, well, investigating. I guess that was. What did you mean by investigation, Sarah? Is that you're going to be doing investigations if things aren't going to plan, whether it's
Yeah.
any of these things?
Yeah. That's like
Yeah.
that's the response. It's like we had some sort of response that says, hey, we got to dig deeper into this problem.
Yeah, audits, meaning somebody that they don't trust you anymore, so they're going to start auditing you in some form or fashion, or loss of trust, right? All of this, or I guess these are all consequences. These are all, in fact, if you look at root cause analysis and you start looking at the impact section of problem statement, these are all various impacts that we might see, and you might mix and match for any, I guess, adverse event.
Yep. Absolutely.
So we're gonna, in a sense, we're sort of defining adverse impacts as the consequences of the outcomes of unreliability.
Yeah, well, it's kind of how it actually manifests, how it shows up in our
Mhm.
day to day is these are the things that we start to see, and those are
Mhm.
those signals that we are not working and operating in a highly reliable scenario.
That's right. Okay. And then going back to RCA, if we're looking retrospectively backwards, then we're looking at actual impact. So one of these or more of these did occur to a certain extent. But when we're looking forward, we're actually looking at potential impact or potential consequences. These
Yeah.
are all the things that could occur. And this is sort of the range of badness that we could experience them in.
Well, and so that's what, like, I mean, we are looking a little bit retrospectively at the moment,
Mm,
but we have the knowledge and experience usually within the organization to project and look at the future of how things can fail. And a lot of that knowledge comes from experience, but it also just comes from knowing how something works and knowing how something is supposed
mm,
to work and how it's supposed to be performed, which again, tying us back to the beginning, was understanding the function. What is it supposed to do? How is the process supposed to be performed? And when we realize we aren't doing that, that's when we understand our reliability is lacking, but we don't have to wait for that lack of reliability in order to do this process.
yeah, and we don't have a slide for this, but it brings to bear how important it is in our own experience. And Sarah and I have worked on a ton of these things, these projects over the years, and I think you'd agree. And if you don't, you're going to tell me. But
I will.
here's what my prediction is that I think there's a
Okay.
low risk that you won't agree with this. That no single person has the knowledge and experience really to do one of these sort of efforts on their own. It's when we get people together where we really understand, like different subject matter experts can really have deep disagreements or deep, I guess, gaps in consistently understanding things like what could potentially happen or what is the probability of something happening. You know, one person might set probabilities low or they might set consequences low, whereas another person, depending on what their specific experience was, may say, no way, I would like me riding, I ride bikes a lot and it's one of my favorite things, but out on the road, I mean, I might have a very different assessment of probability and severity of consequence of something going wrong on a road bike than somebody that doesn't have a lot of experience or operating context. And we might see things totally differently, even if that person might really understand how bicycles function. Their difference in perspective it might be vast, even though technically we're both subject matter experts, but in a different aspect of that domain.
Yeah. I mean, I do
So,
agree. Of course I do agree. But what I'll say is this has been part of such of a theme that we've been talking a lot about is just that the failure modes effects analysis, the RCA, these are all processes of responding or trying to prevent, but they all have that foundation and we are trying to learn.
mm,
And so if we are in a silo doing this by ourselves because we are the subject matter expert, sorry, we end up missing out on that opportunity to learn from others who have a slightly different expertise than we do.
mm. So I think the takeaway is that doing this by yourself limits how effective the process is. It's best, you don't need a whole bunch of people, but it'd be nice to have a team of at least three or four folks that have deep and different experience and
That's
knowledge.
that's actually what Katie and I, when we've been doing some of the
Mm,
FMEAs recently, our one of our biggest takeaways is that having subject matter experts, having technicians, having people who are close to the steps and the process are critical for performing these. That we can meet with, higher level engineers or higher level supervisors and
mm.
they have information about it, but they rarely have like the nuanced specifics and the nuanced experience. And when we have all of those people in a room, the learning just is exponential.
Exponential. I know.
Mhm.
I completely agree with that. It's so important to have the voice of the people who are actually doing the work, who
Yeah.
actually have that direct line knowledge of what's going on. Now, and too often, I mean, I don't know if I'm out on a limb here, but too often those voices aren't in the room when these kind of exercises are happening. And
Yeah.
I think that's a big mistake.
Well, and that's something we always push for, right? Like when we're doing these, is we're always pushing for, can we have, the subject matter experts? Can we have those people in the room helping to answer these questions?
Right. Good. Good. All right. Well, so let's talk about controls. So I added this energy wheel. This is from our friends at Quanta Services. So maybe we'll just say thanks to them for this. This is pretty cool. But when we're talking about controls, reliability isn't creating because nothing goes wrong. It's not if, but when failure occurs. Do we have the capacity to fail safely? It's created because effective controls make success more likely, and controls come in a variety of forms and functions. Most organizations already use reliability controls without calling them that. And I've got a, Sarah, we have a slide coming up that sort of goes deeper into those controls. But I like the energy wheel because when it comes down to safety and you think about the kinds of things that might hurt you or hurt one of the people that we're working with, these sources of energy are extremely important for us to understand prior to the job, right? What are we about to do? Are we going to be interacting with any of these forms of energy? And what are the risks that these things present? I really like this because it's sort of a clear cut. These are the kinds of things that might result in something negative. And so if we are or if we are exposing ourselves to, say, electrical energy, for instance, what kinds of controls, how many levels or layers of controls do we need in place in order to protect us from that particular energy source? And I think that there's probably an analogy, although I wasn't smart enough or quick enough to come up with one for other like quality assurance, right? But there's got to be an energy wheel of quality that could be defined as well.
I think it would probably be, things like foreign debris. Are we going to have dust
Oh yeah.
particles or things like that? Like that, I mean, that's what comes up off the top of my head is when we think about quality, it's like where those slight deviations can come in, and a lot of the times quality issues can come up because of some sort of foreign matter that is there, or that we're just like deviating from our specification, which actually could end up being related to equipment. But there's so many different variables that can revolve around that. But yeah, imagine that there could be a very similar diagram for looking at quality or operations.
Yeah, cool. All right. Well, then let's talk about some of those controls. So in this case, we have I thought it would be fun to map this to a version of hierarchy of controls, and
Yeah.
it's not exact, right? But things like supporting action, right, such as training, checklists, visual management, peer reviews. These are lower on the higher. I think these are important. I want to make a caveat here. I don't want, just because a particular control type, maybe we've put it lower on the hierarchy, doesn't mean that it's not important or that it can't be effective, but that it is subject to a higher degree of variation. And that higher degree of variation needs to be taken into account.
Hmm.
So things that are higher on this particular hierarchy of controls chart, they're more reliable and sustainable because they actually systematically reduce risk in that particular system or in that particular environment. Some environments don't lend themselves to that. And in some cases, I could even make the case that, it's not me making the case, it's me agreeing with the case that others have made that engineering controls can actually make the people in those environments less safe because it limits their options to respond. And so we can talk about that. Like there are certain environments that are just inherently variable. And so you don't want to tie somebody down with a lot of engineering controls because they might need to have the option to make decisions or alterations in the moment. And sometimes those engineering controls can actually box them in. In any case, the point is that even though things like training or checklists or visual management or peer reviews show up lower on the hierarchy of controls chart than something like an engineering control or an automation or a redundancy or an alarm, I guess I've tempered my thinking over the years to I guess recognize that these are important controls and that when we have opportunities to put them in place, we should do it. And knowing that they may be subject to an inherently larger level or higher level of variation based on where they fall, knowing that that's the case, we can do some things to augment that, even if we can't push the control itself up the hierarchy. But I thought this was kind of a neat way to sort of tie into what we already teach. In RCA class, we talk about solutions. and we're looking for solutions that are, well, we're looking for the best possible solutions and mapping that onto the hierarchy of controls, I guess, framework is a way in which we can decide what represents the higher quality solutions. And at the same time, knowing that it's more about the combination of solutions or controls that we put in place, them acting in sort of a diversified way that limits or reduces risk versus sort of looking in root cause analysis, for instance, for single root causes of complex events that we then control. In this case, we're doing the same thing. We're looking for a variety of different control methods so that we spread the risk. Um, and that spreading the risk, the diversification of risk, is the most effective strategy for controlling overall risk of whatever it is that we're trying to, I guess, improve or trying to help me get out of this. I can't stop
Well,
talking.
and organizations that are identified as highly reliable organizations or HROs, those are the organizations that have the combination of things. And they even will tell you that, like, yeah, we still have checklists. Yeah, they may not be the best thing, but like we still do that and we follow them every single time. And so part of it is having that rigor around what they're doing to be able to know, hey, we've got to do this every single time. But they still have engineering controls and they still have alarms. But those things, I mean, even those things as an engineered solution may not always be the best. I toured a nuclear power plant one time when I was at like a conference, and there was an alarm going off in the control room, and everything was shut down. Like nothing was operating when we were there, but there's this alarm going off, and so I just asked him like, what's that? And the
Mhm.
response from the technician is like, oh, that's a nuisance alarm. Like that's just not a big deal. And I was like, oh, that makes me uncomfortable. Like, what's the point of having this thing if it's just
Mhm.
going to be a nuisance? Where our reliability comes in is when everything has that purpose and we know that those controls are in place for a reason. They have a goal. They're doing a specific thing. And yeah, it can be anywhere on this hierarchy, but having that diversity. And I think that is a very key point here is like having that diversity of the types of controls that are in place is where we end up getting our maximizing our reliability levels.
Mhm. I think it's important to note that controls aren't without cost, and
Oh yeah.
there's a tension here that comes in to into play, and often it's outside of the team that we have that's looking at whatever process equipment system. And that tension is every control we put in place comes with a cost, and it builds margin, so margin meaning margin, I guess the easiest way to describe margin is that there's room or capacity for I guess if a failure happens, then there's buffer. But
Yeah.
there are some folks in the organization that look at buffer as waste. And
Mhm.
you're trying to optimize. Like, are you sure? Is there too much buffer here?
But that
And
gets back to when you were talking about risk, though, as you were saying, like it all also is going to tie back to risk. And in certain situations, that buffer is probably necessary. And in other organizations, they're going to see that as waste.
yeah, but I guess what we've seen is that when the problem doesn't happen again, then all of a sudden, and there's some time goes on, can mean the risk of something occurring and the fact that it hasn't happened, and it's like, well, it hasn't happened yet, therefore it won't happen. It hasn't happened yet, therefore it's not gonna happen. I think that's a very dangerous sort of a, I guess, that's a dangerous sort of conclusion to come to because without a clear understanding of the risk profile. Risk doesn't mean certainty. In fact, it's risk is literally the measurement of uncertainty. And just because something hasn't happened in a while, that you see things trend back to or fall back to the mean, so we want to make sure that just because things aren't happening, that we still remain vigilant with our with things like you said, Sarah, checklists, peer reviews, training, etc. That vigilance is what holds that risk into an acceptable level.
Yeah.
Okay. So, which controls are preventing failure, and then which controls respond only after failures occur? Yeah, so I think these are really neat questions. These are your questions, and where were you going with these?
Yeah, well, we have these different types of controls that we put in place and we identify them through different practices. But this, you mentioned safety capacity a few different times. That's our ability to fail safely, where we have these controls in place that sometimes stop the bad thing from happening. And then we
Mhm.
also have some things in place that come in after the failure that has occurred to try to help minimize its overall impact.
10-4. That makes perfect sense. I see the clock, I'm watching it, and then I think
Yeah,
that let's move to let's move to the example, which is this
let's do
shift
it.
handoff. All right, so everyone has some form of handing work from one person to another. So healthcare, manufacturing, utilities, there's a lot of different examples here. And so Sarah pulled this example together. Do you want to explain it? Because I bet they're sick of hearing my voice.
Sure. I mean, as you just said, like everybody has some sort of handoff that occurs in your work environment. Whether you are talking about healthcare or manufacturing or oil and gas or even IT. Any type of industry is going to have this shift handoff that happens from one to another. And when these don't go well, sometimes our reaction is we're going to have more meetings, we're going to write more stuff down, we're going to communicate better. There are these very generic and vague responses
Mhm,
that tend to happen. And so we thought, like, hey, let's take a look at this. We're doing
mhm,
a shift handoff as our process that we want to have be more reliable. So in this scenario, nothing's broken. Like nothing has broken in terms of a component. Let's say we're talking about a manufacturing facility in this scenario. Production is continued throughout the day, but there are things that change during the shift and things that come up during that shift
mhm,
change that need to be communicated from one shift to the next shift. And so that's kind of where the discussion goes to on this is if we're looking at this through the lens of reliability, how can this shift handoff fail? Um,
mhm,
and there's lots of possibilities here in terms of how it could fail. Maybe there's temporary operating procedures, as an
mhm,
example. Oftentimes, when we go from one time frame to another, if something changed in our first shift to the second shift, we implement these temporary operating procedures. We want to
mhm.
understand what those were, how are they in place, how long are they supposed to be in place, and there has to be a process for making that transition smooth.
Hmm. Okay, well, let's continue through there. So if you were, so now, actually, before we go, so system, shift handoff, right? That's the high
Yep.
level. The element that you're looking at is handing work from one person to another, from one shift, like shift A to shift B, right?
Mm-hmm.
Yeah.
Yep.
And then the function, you've got this, the function is defined. And so then we can move over into what we would call failure modes, consequences, and controls, right? So by systematic, like this is kind of what it looks like. We do this in a spreadsheet, but when we're being systematic about it, right, we're looking at, sort of an exhaustive possibility of the ways in which we might fail to hand that information off.
Yeah. So our goal is to be able to communicate effectively from like you said, shift A to shift B. And
Hmm.
so each one of these then is a failure mode that could happen. And now
Hmm.
we may have had experience with some of this, or these could be things that we have just created. So, for example, the first one that's listed on here is a critical operating information is omitted.
Hmm.
Our consequences can vary. The consequences can be severe or they could just be somewhat mild.
Mm.
Here we're saying, so our incoming shift is unaware of some of those abnormal conditions. That means
Hmm.
if they aren't aware of it, they may not know that there is risk of something getting damaged or some sort of incident that could happen. An idea of a control, the first one that's listed on here, is a checklist, a way of going through and making sure that they know these are the current status. Here's where anything that's different, anything unusual or unique that's going on.
Hmm. and then to just sort of outline, we bring the team back in. When we're our diverse team does is they help make sure that our universe of possible failure modes is as complete as possible. And that's when Sarah mentioned bringing in the people that actually do the work. That's how we make sure that like they're going to tell us what really happens, right?
Mhm.
And then we can also hear what the real life consequences are. We can see how far they go. And Sarah, one thing that I noticed that you did here, which I think is important, is you're kind of looking at the outer boundary of how bad they could be, and recognizing, of course, that on the lower boundary, it could be zero. In fact, most of the time it is zero. Mostly, like they could eliminate critical operating information, and it's possible that nothing happens, or it might even be probable that nothing happens. And but it the outer boundary or the worst case is that these things that you've listed here. And then this is the sort of control that you would, based on what you think those consequences are, then that should drive the level of control that you find acceptable.
If we look at, from like a small level, and this is probably something that would never even be noticed or acknowledged, but if we're in quality and we're doing an inspection and somebody is in the middle of doing an inspection and their shift ends, and so they put it on the shelf and they stop and they pause what they're doing, if
Mhm.
they don't communicate effectively where they are in the process of doing that inspection, then what we start to see is the rework of somebody's going to go, they're going to start over
Mhm.
and they're going to do it again. No one's probably ever going to know that.
Mhm.
But that's
Mhm.
the part of if we want to make sure that we are doing our work at the best level that we can, if there's a process in place to communicate where we are in a certain step or in a certain function, then
Yeah.
that only sets us ahead going forward. So that's a scenario, right, where it's not going to be that big of a deal. If someone
I
already did
love
part of it, they're going to do it again.
I love what you just said because that can often that kind of gets on the other side. That's when we're basically overcompensating for risk. So we don't have a process in place. So person A or worker on shift A starts the inspection process, but then they have an incomplete or a shoddy handoff process, or it doesn't exist at all. Shift worker B comes in, they pick up, they don't know, right? Because they haven't communicated. So they're like, probably best for me to start that inspection all over again. So they redo work that's already been done. So now they've overlapped work that wasn't needed in the first place. That
Hmm.
represents waste. That
Hmm.
represents scrap. And that's exactly the kind of thing that so people that are looking for waste and scrap and optimization, they're looking for those kinds of overlaps so that they can try to minimize that overlap. And so with that sort of is the other, I guess, benefit of doing this is that you can more responsibly identify sources of unneeded margin or unnecessary margin and then eliminate those. And so you can actually do process improvement along the way, not just risk mitigation. And one
Hmm.
of the things that I've been subject to is the fact that in the past, we're fine with adding margin and we're a little uncomfortable with deleting it, you know? Like I don't want to
Yep.
take that away.
Yeah.
Anyway, good, good. Well, let's move through then. So now we've got some
Yeah.
practices. So this is the practical application, the takeaways, right? So one of them is clarifying what must go right. So going back to the shift handoff, before a single word is exchanged, reliability thinking asks one question: what must this process do successfully? And so transfer, that goes back to the function, the statement of function. Transfer accurate operational knowledge so work continues safely and effectively. And so then the question, what would show that the handoff is no longer meeting its function, right? So how would we know that I guess that this handoff is occurring? How would we know that it's effective
How would we know that it's effective or that it's not being effective?
or not being
Or not
effective?
being effective. I mean, how it's being
Well,
effective
yeah.
is probably, with feedback from our technicians of do you know what the next steps are, what the process is, what's going on. But where it's no longer meeting is where we see some of those outcomes, where we see rework or we see defects or we're seeing actual problems occur.
Mhm. Honestly, so what this sort of maps over, what I'm thinking right now is that like this sort of maps over to a mini plan, do, check, act cycle.
Absolutely.
right? Plan, do, check, act, plan. So that when we put these things in place, that we recognize that these are living, that these are situational, that they are not absolute and forever. This isn't a brick wall, right? This is something that needs to be that needs to be, I guess, semi. I don't want to make it so that it's completely, like like overcooked spaghetti, right? But we don't want this to be brittle either. We need it to, I guess, adapt and improve over time in each one of these steps that we look at. Let's
Well,
look at
and
this.
it needs to be able to respond to the variables too that get introduced. I like that analogy of it being too brittle, because if you introduce a variable and it breaks, then
Mhm.
that handoff process isn't successful.
Yeah, yeah, yeah. Okay, let's move to the second practice. Identify how work can break down. Okay, so once we know what the function is, look for a specific way in which that function might fail. So 9 failure modes surfaced in the handoff story. In case you forgot them, there they are. Okay, there you go. That was your reminder. But that was enough. They
Pretty
can push
pause.
pause. They can push when they look at it. They can zoom in. 9 failure modes surfaced in the handoff story without a single piece of equipment breaking. Right. Critical information is omitted, communicated inaccurately, or documented but never discussed. These are examples. So, where are people most likely to rush, skip, or work around this process?
Yeah. And that's what we see. I mean, that's how it manifests sometimes is people will say, "Oh, well,
Mhm.
we have this process in place, but it's not working." So then they just don't do it anymore.
Or nothing bad happens, and they think that the process itself
Oh,
doesn't
it
isn't
works great.
needed. That's right. They don't recognize that the process is the barrier,
Hmm.
right? And that it needs to be done. Yeah, interesting. Okay, so let's look at practice number 3. Focus on the consequences that matter most. Not every failure mode deserves the same response. Some risk equipment damage or safety incident, right? So others just cause delay. So high consequence failure modes, such as temporary workarounds not being communicated, known risks are unknowingly inherited by the next shift, right? So if these temporary workarounds aren't communicated from shift A to shift B, then shift B is going to essentially, it's like you're kind of throwing them a hand grenade, right? Like there's things there that might blow up in their face, but they're not aware of it. And that's not great. So does the current control match the seriousness of the consequence?
Hmm.
Excellent
Yep.
prioritization and making sure that we're not over controlling as well because sometimes the current control over matches the seriousness of the consequence and that can be very frustrating too. Okay, so maybe we'll move to practice 4. Evaluate the strength of the controls. So let's test whether each control actually works, not just whether it exists. Assigned checklist proves an activity happened, but this sounds like the pencil whipping approach, right? It doesn't, if it, just because they gave, look, I did the paperwork, I did the checklist just like you wanted. The pre-job hazard assessment is all filled out, so I did my part. It's like, yeah, okay, that's fine. But would it still work if the handoff was rushed or interrupted? I guess this is the question that you came up with here, but what might cause that to break down, right?
Mhm. Yeah. Is would be, I mean, we're looking at how, I don't know if rigorous is quite the right word, but how much room there is within our controls for them to be successful if there is something that steps in its way.
Right. And so these are the 4 that you pulled out and said were most important. Clarify what must go right, identify how work can break down, focus on the consequences, prioritize, and then put controls in place that right size to those consequences. But then now you've got 6 more practices here.
So
Recognizing,
these all came from the blog that was on there, of ways to focus on improving reliability amongst other types of disciplines. And
right.
these are important. I'm certainly not minimizing their importance in the process. I just think, as we're starting to look at reliability improvements, the first 4 I wanted to go through, but these are also equally important. We're recognizing weak signals. If we have something that is supposed to give us a piece of information that we need to make an improvement, like acting on it quickly, looking at those small deviations, looking at those small things that are changing in how we do things, those are our signals that something may not be quite right.
hmm
So that's
hmm
the first one that's on here.
Improving
Um,
pre-job planning.
yeah.
Yeah, confirming that those, like for instance, just making sure that our pre-job planning is not backsliding, I guess. Make
Hmm.
sure that it's useful as well, but that we're identifying controls, identify sources of failure and controlling those. Making audits more useful. Okay, that definitely. Audits themselves, testing whether the control performs, not just whether it's documented. Here, you take the next one. What's this one?
Yeah, so strengthening the management of change, I mean, that gets down to ownership
Mhm,
of who actually knows what the change is and are they communicating what that is. The temporary procedure example, if somebody owns that procedure,
mhm,
knowing that that's there so that as that change either is enacted or removed,
mhm,
that communication still happens.
mhm. And looking
So,
at repeat problems, right? So surfacing those. Sometimes, and one of the things that came up in the meeting that we were at yesterday is being able to even see that repeat problems are happening because depending on what you mean by repeat, certain people may not have visibility across the broader system. And so, unless they're in a position where like problems are being reported and they're percolating up, then it may be hard for a person in one site, for instance, to see that the exact same problems are happening at two other sites because they just don't have that organizational visibility.
and then it's meant to represent like, do we have the same gaps that keep recurring? Do we keep
Right.
having the same miscommunications over and over again and just tell people, hey, make sure you remember to say that next time?
Right. And then prioritizing spending the most effort where consequence and weak signals are both the highest. Yeah, especially where those two things meet up, because then those are the most critical areas.
Hmm. Absolutely.
Excellent. Well,
Key
key
takeaways, are we
takeaways.
there? It
Friday is coming to a close.
is.
I think
It is.
both of us are wrapping our day up after this. Is that right?
And yes, I am planning to start my weekend here shortly. But um I do. I think that the way that this information, thinking about reliability, we do focus
Mhm,
usually so heavily on components with it, but the way that it expands itself to processes and workflows and tasks and jobs, that thought process, I think, can be what is so critical for our workers and for our people who are really doing the efforts to see where the improvements can be.
mhm,
Because people want to do the good job. Like people want to have that outcome. So yeah, not just looking at the equipment, but also looking at how we do this in other ways.
mhm, mhm. And in like every function, everything can be defined kind of from a hierarchy, right? A taxonomy. You break
Mhm.
it down, and then you can when you understand how everything flows together, or everything like what everything is supposed to do in the system and how they all function together, then that gives us the granularity that we need in order to apply this reliability thinking. Yeah.
Agreed.
Do you want to take the next one?
Sure. Looking at things proactively. We are accustomed to responding to the
Mhm,
problems, but this is what turns it around and it allows us to look forward and say, what can we do differently? How can we prevent these problems? And again, some of that just comes from the experience of knowing how something works.
mhm,
But it's trying to get us ahead of fighting the fires.
mhm. And the universality, right? That we apply
Mhm.
these same four questions regardless of where we're applying this process. And then why don't you take like what's the last step here,
Start
which is
start
always great.
small.
Yeah.
Yeah, I mean, sometimes people enter thinking about reliability and think it's going to be too hard, too much, it's too complicated, I can't do it. It doesn't have to be. It can be something
Mm,
so simple. I was looking
mm.
I was looking at this recently. Maybe you saw I put this on LinkedIn where my son has a checklist for getting in the car and it's simple things like have you gone to the bathroom? Have you
That's
washed your
not a simple thing. That's an
have you?
important
Oh
thing.
my goodness. And when he was 3 years old, I could not get him into the car. Well,
Yeah.
it's a simple task. but things can go wrong because if you're a 3-year-old who doesn't have your favorite stuffy, like that's a big deal.
It's a big
And
deal.
so I mean, you don't need to start with something like that, but starting with a simple process or starting with
Uh,
something that is relatively simple, you will be surprised that there are complexities to everything that we look at and there are nuances with it, but
mm,
they don't have to be, the major conveyor system or they don't have to be a critical cleaning process for a sanitation tank. Like it can be something that is in a day-to-day doesn't
mhm.
seem like a big deal, but there still can be so much learning that comes out of it. So that's our suggestion is pick a process, name its function, tell us what failure looks like. And then maybe you can identify ways for improvement in it.
In fact, you can almost make the argument just like you shouldn't just wait to boil the ocean or try to solve, some kind of a global crisis. That you should just always start with the small things first. Pick something that's irritating, that where the
Mhm.
consequence itself is like, the worst thing that comes out of this is I get so annoyed.
Yeah. Yeah. Well,
But I don't know, like that something that's easy, and then because when you model it on something simple, low consequence, but easy to succeed at, and then it makes it much easier to scale.
I had somebody tell me they recently did something like this for forgetting their lunch. They were like, I forget my lunch half the days, and I just can't remember. I just can't seem to remember to get my lunch. I'm like, well, like, yes, that's a problem, but like this is a process. There's something in there. Maybe that can be the start simple is how do I make sure I don't lose that or how I don't lose my keys or my phone or anything.
Yeah.
There's simple ones out there that still can be good learnings.
Seriously, yeah, I was gonna
Well,
say I do not have that problem of forgetting to eat lunch. Oh,
you
I
never
forgot to
forget your
eat
lunch.
lunch today. No, I have a pretty robust system in place. All right, let's do this. So we're pitching our learning
Yay.
summit. This is going to be in Seattle on October 7th and 8th. This is going to be super fun. We have some great speakers, and I'm going to just do this because I think I have it pulled up over here. Oh, I did have it, but watch, I'm gonna do this. So Logic, this is what you would do. So logic.com, it's just like what I'm doing. And then go to the 2006 Learning Summit. And
There it is.
then, wow, about the summit. This is amazing. Look at all this awesome information. And it's all right here. And I do want to highlight a couple of things. So, we're going to have Leslie from United. That's going to be super fun, talking about learning in action. There's Jamie Laughlin. Oh my goodness. So she's our
That's
original
exciting.
contact at Amazon. And now she runs the JLL account for Amazon, and she's going to be coming out. She hasn't told us what she's talking on yet, but I know it's going to be something kind of like what you and I just discussed today. We have Chris Hansen. He was formerly at NASA, but he's going to talk. He's doing this great presentation on well, an example of an extravehicular activity where an astronaut was at severe risk of being injured or possibly worse through the buildup of condensation inside their helmet. Very cool learning event. Ron Gant, the amazing Ron Gant, is going to be coming out to talk to us about where organizational learning is heading. He is a visionary, whether
That's
he describes himself.
exciting.
He's that's pretty great. We're gonna have Ian Small from Mortensen. Ian and I have co-presented multiple times over the years. Super smart guy, really a down-to-earth dude when it comes to put applying safety concepts right in the field and making sure building trust with people that are working where the sharp end of the work happens. Laura McGuire, this is going to be another amazing experience. So Laura is one of the smartest people in resilience engineering, and she's super interesting, super cool, and looking forward to that. And then Lauren from Massachusetts Bay Transit Authority, along with our own Katie Fry, is going to talk about what they're doing at MBTA over the last few years. So sprinkled with us, others of us, and then a lot of fun and learning along the way. We were a fun crew, if I do say so myself. And I think if you come to our learning summit, then you will also have fun, learn, improve, meet friends for life, probably. And all it takes is clicking the register button. How was that for a pitch?
I love it. I mean,
Should
it's
I
so
do it?
exciting. It's
Are
gonna
you?
be really great, and it's such a great group of folks that are gonna be together for it.
Oh,
So
and we have good incentives too, right? So if you pay for three, you get a fourth for free, and other possibilities as well of participating. So, all right, well, let's let everybody get to their Friday. What do you think?
I think so. Thanks,
Oh,
guys. Oh,
wait.
what?
There's a very important lesson to all of this. Can you guess what it is?
I don't know. Oh my God, you did it. All right, Brian,
Sarah, we
I
need
will
to
never
know
leave
when to
you.
stop.
I
We
will
need to
never
know
leave
when
you
to stop.
alone with the slides ever again.
We don't want to shave the yak with these things, Sarah. I just think it's important. I just really do. Like we need to know how to how to scope these things and make sure that I mean, I'm just saying, like there's a point of diminishing returns.
I really hope people disconnected when they heard about the wonderful summit. And then they said, this has been
Oh,
great.
well,
This has been fun, Brian.
let's put everybody out of their misery.
Thanks, guys,
Okay,
for being
talk
here
to you
today.
later. See you, Sarah. Bye.
See ya.